This is another concept bite video for the Master of Chemists course, this time on the concept of standard error. In previous videos we've looked at the standard deviation, and I show a pretty typical profile for standard deviation in the bottom right of the screen. We can see that within one standard deviation of the mean, about 66% of my data lies. Two standard deviations covers just over 95%. I expect to find an equal distribution of data above and below my mean value. And I do not expect this standard deviation to change no matter how much data I collect. In a previous video I calculated the standard deviation of the dataset shown here for the initial rate of reaction as being 0.09 times 10 to the minus 4 moles per decimeter cubed per second. This is based on the fact that I've taken 5 measurements, but even if I increase that, I shouldn't expect my standard deviation to differ too much. However, you would expect that you have more confidence in your mean value the more values you take. This is where the standard error comes in. The standard error, shown in this calculation here, links the sample standard deviation to the number of samples that I've taken. This means that the more samples I take, the higher confidence I have in my mean value, and the smaller the error or uncertainty associated with that mean value. Standard errors are normally ever reported to one significant figure. Sometimes if the standard error begins with a number beginning with 1, then it is reported to 2, but it's normal for standard errors to only ever be reported to one significant figure. Something else to consider is that because the standard error is a measure of the uncertainty of our mean, the value should always be rounded up, regardless. So, in this calculation, based on the data I had earlier, I can calculate my standard error from the standard error equation. And I find that when I have this value, I have rounded it up to 0.05 from a value of 0.0402. Because I always round up my values to standard error and I present them to one significant figure. When presenting standard errors, use of this bracket notation is quite common. It makes it easy to see in what values the uncertainty lies, and it makes it easy, particularly if we have a number of values, if my uncertainty is a number of times after the decimal place. One thing to consider with standard error is sometimes after we've calculated it, we need to change our mean value. Because the standard error is only ever reported to one significant figure, I can sometimes have to change my mean and reduce the number of significant figures it is shared to. We should only ever reduce the number of significant figures, we should never try to increase them. Here I've presented a mean value of 2.13. And when the standard error has been calculated, it rounds up to 0.2 because it is 0.184. This means that when I have my mean value, the 2.13, because the uncertainty lies in that 1, it makes absolutely no sense to have a false level of precision with that 3. Therefore, the mean value gets rounded to 2.1 and the value and its uncertainty gets presented as 2.1 bracket 2. I hope this has helped. I'll be back with more.